Hello, today we are talking about Chapter 2, Lesson 4, Identifying Proportional Relationships. We're going to begin here on page 148. In the beginning here, we have some vocabulary words that are brought to us. Now, it says here, two quantities are proportional if they have a constant ratio or rate. So when we did the first real-life example previous to this page, we had a constant ratio happening of $8 for every pizza. So when you have a pattern like that that keeps repeating, when you have the same amount of something every single time for every given certain amount, for example, 8 to 1, 16 to 2, 24 to 3, just like we had in the previous example, then you have what's called a proportional relationship. However, for relationships in which this ratio is not constant, and this is just as important to know, the two quantities are non-proportional. You might have something that's increasing by 1 or 2 amounts, or 3 or 4, something that's not the same every single time for every single amount. And we're going to discover what that means in just a second. Now, in our previous example on the page before, we had some pizzas that were being ordered. And we found out that when we ordered one pizza, we paid $8, 2 pizzas, 16, 3 was 24, 4 pizzas, 32, and five pizzas, for $40. And that was based on because each pizza, no matter how many we ordered, would always be $8 per pizza. So once we establish that fact, we could establish what's called a proportional relationship. We can find basically the cost of any number of pizzas based on how many pizzas we want to order. So as long as we know how many we're ordering, multiply times 8, and that's how much it's going to cost. That's a proportional relationship. You will always have multiplying or dividing happening in a proportional relationship, not addition or subtraction. And you must know that now. And as a matter of fact, I think we should actually write that down on the side. Proportional relationships always have multiplying or dividing going on. And we will discover exactly what that means as we keep going on. Also, another thing you'll discover with proportional relationships is that you'll have equivalent ratios. If you look at all these ratios up here, and I'll kind of single them out by circling them red, all these fractions, which are also ratios because we're comparing two things, when they all get simplified, they simplify down to 8 to 1. Because all of these equal 8 to 1, that means they are equivalent ratios, or basically equal fractions, if you want to think of it that way. Equal fractions. So let's go ahead and move on down to example 1. In example 1, it reads, Andrew earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing? Explain. So determine the amount of money he earns for working a different number of hours. Make the table to show these amounts. So here's what we have. It's $18 per hour. Now, one thing you want to listen to is whenever you have something like that, that's telling us we have a relationship. It's basically our unit rate. $18 for 1 hour. This looks vaguely familiar to another problem we saw earlier. Now, here we have a table already made for us in time. Let's say he works 1, 2, 3, or 4 hours. Well, if he charges $18 an hour, then 1 times 18 is 18, 2 times 18 is 36, 3 times 18, 54, 4 times 18 is 72, and so on and so forth. We could predict how much money he'd make given any number of hours. So, because we have this same relationship all the time, times 18, times 18, times 18, you can make yours look a lot nicer than mine. Writing on this board is not that easy. All of these, because something was multiplied times something else, then we know we have a proportional relationship. And as a matter of fact, we can prove it also because we can show that we have equivalent ratios. So let's say we take the second example here, $36 for 2 hours. Well, if we simplify that by cutting everything in half or dividing by 2, we get 18 to 1. Let's say we take this third example right here, $54 for 3 hours. Well, if I divide everything by 3, we get 18 to 1 again, excuse me. There we go. So, and we know we'll see the same thing over here. So we have equivalent ratios, and we have something being multiplied all the time. In this case, it could be divided also, but it's multiplication here. Then we know we have a proportional relationship. What also gives it away was this per hour. When you have a unit rate of just something per 1, you always have a proportional relationship. Let's go ahead and continue on to the bottom of this page. And you have the got it A. You're going to go ahead and work this one on your own, and I'm going to skip ahead to the next page. Now we're on page 149, and let me go ahead and move to the top. Here we have another example. Uptown Tickets charges $7 per baseball game ticket plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? Explain. So here we have this kind of complicated situation. It's $7 a ticket. All right, so I know I can multiply any number of tickets times 7 and figure out the price. That's easy. But it says plus a $3 processing fee per order. So that means I'm paying $3 no matter how many tickets I order. And that kind of changes things up a bit. So we have the one thing we like here in this story, which is $7 per baseball game. $7 one game. So far it's looking good. But then we have this plus a $3 processing fee. And I'm a little nervous about that because I know proportional relationships always deal with multiplying or dividing only. Let's go ahead and look at the data table we have here, or this chart. So one ticket times $7 is $7. But remember, it costs $3 just to make the order, so we paid 10. That's what happened here. If we ordered 2 tickets, well, 2 tickets times 7 is 14, but we got to pay that $3 order fee. That's 17. 3 to 24. I understand how this works. 3 times 7 plus 3, 4 times 7 plus 3 gives me these amounts, but I have to keep doing this extra step. So let's go ahead. I still can't tell because the process is the same. I keep multiplying this number times 7, but then I keep adding that 3. So let me go ahead and then look at the ratios now. I have my first ratio here, my unit rate, and it's $10 in this case, because remember that fee for one ticket. If I look at my next one, I have 17 to 2. Well, if I divide it by 2, I get, what is this? 8.5 to 1. Okay, that's different. Let's look at the next one, 24 to 3. Well, these are nice numbers. I can divide the top and the bottom by 3. And I get 8 over 1. Okay, so I had 10 over 1, 8.5 over 1, 8 over 1. Let's look at this 31 over 4. Okay, so I'll divide everything by 4 because I want to get a unit rate. 31 divided by 4 is going to be 28, 29, 30, and 3/4. No, none of these are the same. These are all different. So because they're all different, this is not proportional. I'll give you guys a big hint right now. Whenever you have something being multiplied or divided, which is what we like, but then we have something tacked on like plus or minus, to the whole total, then it's not going to be proportional. Most of the time, that's always how it's going to work. And you're going to discover that as we go on through these examples. And as a matter of fact, let's look at number 3 down here. Now it says you can use the recipe shown to make a fruit punch. Is the amount of sugar used proportional to the amount of mix used? Explain. So now they don't give us much information except they're making us just look at a table. They're not giving us, unfortunately, a unit rate. But actually they are, because the unit rate is something compared to 1. And if I look here, I have cups of sugar compared to envelopes of mix. Well, I have half a cup of sugar compared to 1 envelope of mix. That's actually great news for me, because once they give me something compared to 1, I know, bam, I have a unit rate. So I have 1/2 compared to 1. After studying complex fractions, I understand it's not a big deal. Half a cup of sugar to 1 packet of mix. I can understand that in my head. So there's nothing really mathematical crazy going on. So let's keep going and see what happens with the next ratio. Here I have 1 to 2. Okay, 1 over 2. That's a fraction I can handle. Here I have 1.5 to 3. Okay, 1.5 over 3. That looks a little odd, but I can still kind of live with it. And here I have 2 to 4. Now the test to see if these things are proportional is to see if they reduce or simplify to the same ratio all the time. So let's go ahead and examine them. 1/2 divided by 1. Well, I know 1/2 divided by 1 is just 1/2. Here I have the fraction 1 over 2, which is our friend 1/2. Looking good so far. Here I have 1.5 divided by 3. All right, so 1.5 divided by 3. I'm going to change this into a decimal for now and say, okay, I have $1.50 divided into 3 parts. What number times 3 will give me $1.50? Well, that would be 50 cents. Bam, 1/2. Same thing, fraction form. Here, 2/4. I know I can divide the top and the bottom by 2, and I get, once again, 1/2. Oops, make my little arrow there. So because I have the same constant ratio here, I know I have a proportional relationship. It doesn't matter if I have fractions and they look scary. When I really look at them, I realize they're not that bad and they're a lot easier to work with probably than decimals. So now it's your turn to do got it be. After you've completed this, we will work on example. The next example, I believe, was number 4 on the next page in class. Good luck.